All right, so if that's what happens when you add a constant, what do you think should happen when you subtract? Shift down. All right, what if you add something inside the parentheses? If adding outside of the parentheses moves up or down, what should adding inside the parentheses do you think? Shift it left and right. If you add a number, do you think it should go left or right? Folks for left? Folks for right? All right, so those of you who said right, you're thinking very intuitively. That's the obvious answer, right? It's the answer that's obviously right? But let's just see what happens. So, don't need that anymore. F of x plus 2. If you have the red graph, how would you say you generate that green graph? Does that look like it's shifted to the left or to the right? Left. And this is a general thing that we'll see in a few different examples. Whenever you do something inside the parentheses, it does kind of the opposite of what you would intuitively expect. And if you like, that's because whenever you do something to the input and you think about what that does to the graph, you would have a step where you would want to solve for x. So the step you would add that x, add that 2 to the other side, making subtraction. That's not necessarily so important. Just remember, whenever you do something inside the parentheses, it does the opposite of what you expect. When you add a constant on the inside, you will shift left by that number c. So what should happen when you subtract a constant? Yeah, exactly the opposite. Groovy. Folks feel pretty okay about this idea? And what's the important thing here? The important thing here is that now any of those functions, those elementary functions we've talked about, if you know things about them, you know things about things that you can build out of them with these moves. So here's an example. I think I don't want Desmos now. F of x equals x squared. Is that a graph that we just know what it looks like? Yeah. It's intercepts at 0, 0, and then it is bowl-shaped. Parabola if you want the technical term. So let's do that. Goes through 0, 0. At plus or minus 1, it is 1, and then it fogs upward. There's the graph of y equals x squared. And let's suppose that we want, eventually, the graph of, oh no, both of these, x plus 2. So that'll be x plus 2 squared. How would you go from the blue graph to this graph? Left 2. So this point here at 0, 0 will become the point at negative 2, 0. And then it will curve upward. So it'll look generally like that. Do you think we should be careful and get the y-intercept correct? May as well. How do you get the y-intercept of a thing? How do you get the y-intercept of any function? Plug in x equals 0, see what happens. So let's just check and make sure we have the y-intercepts correct. That means we should plug in x equals 0, y equals 0 plus 2 squared. What is 0 plus 2 squared? 4. All right, the 0 doesn't matter, but then there's a plus 2, 2 squared is 4. 1, 2, 3, 4. So it should go through this point. Folks feel all right now? Cool. The other one was f of x equal to, f of x plus 2. So that'll be x squared plus 2. How should you shift the graph to get that? Up by 2. So this point at 0, 0, let's move it up 2. It'll curve generally upward like that. At a glance, does this look like it'll have any x-intercepts to find? No. We could check if there were. You guys are looking at the corner like you think there's a bee or something. Oh, there's a little bug there. Oh, hi, bug. Doesn't look like a bee from here. Oh, good. It's probably fine. Just don't throw anything at it. Those ideas seem sensible? Nice. So, let's try the same sort of thing. Let's put these different steps together. Let's try to get the graph of Well, if f of x is the square root of x, let's try to get the graph of f of x minus 2 plus 1. So that'll be the square root of x minus 2 plus 1. So I guess we better start with the square root of x as the starting point. Is the square root of x a graph that you just know what it looks like? Yeah, it looks like half a parabola, but the y's and x's are switched. Ooh, let's do something slightly wrong. Why is that not right? Yeah, this says that 0 is not in the domain. But what's the square root of 0? So that means you can plug x equals 0 in. So 0 is in the domain. Solid not there. Alrighty. So I would eventually like to get the graph of square root x minus 2 plus 1. And for now, I'll advocate dealing with those two things that are interlined in Popple in two separate steps, though it'll become clear that we could do it all at once. Let's start with, I don't know, the x minus 2. So if you wanted the square root of x minus 2, what would you want to do to the graph? Shift it right by 2? Cool. Let's do that. So this point here at 0, 0, we'll travel right by 2 to the point 2, 0. And now, let's make it look like the square root. All right. So far, so good. I still need to deal with the plus 1. What will that do to the graph? Up by 1. So that point that right now is at 2, 0 will become 2, 1. And then it'll just still look like the square root. All right. That feel good enough? And hopefully today feels reasonably light. So the whole point here is you can now put these moves together. And you know what? Maybe I'll have you do exactly that. Put those moves together. Give me the graph of the square root of x plus 1 minus 2. And maybe I'll give you all option here. I can just be quiet for a few minutes and you can do it, or I can keep talking. They demand for me to keep talking. All right, then I'll be quiet for a bit. Cool. So, let's see. The end result would be a graph that looks vaguely like the square root function, except I guess it'll be shifted some. When you do those shifts, this point at 0, 0, where will it travel to? Where will it end up? Yeah. -1, -2. And then I guess from there it'll look like a square root function. So I'll sketch a bit of a graph and then we'll decide if we want to check something. Yeah, that doesn't look very square rooty. Let's make it clear that it levels off. So let's talk about what you should be confident in that this graph does correctly right now. I think that point at -1, -2, we should definitely be confident in right now. Because we cared about that point when we did this computation. How confident do you think I should be in the precise value of those x and y intercepts? Probably not terribly confident because I just freehanded it, right? Could we check the x and y intercepts just directly right now? Yeah, let's do that. Let's start with the y-intercept because it's the easiest one. How do you find the y-intercept? Set x equal to 0. So start by getting the y-intercept. Set x equal to 0. And I don't know, you do some stuff, what do you get for that y value? I hear a -1. People agree? Nice. So that means 0, -1 should be on the graph. That's pretty close. Of course, I didn't have much space to drift in the meantime. What about the x-intercept? How do you find the x-intercept? Set y equal to 0, and then I guess you actually have to do some algebra to find x. So to find the x-intercept, you set y equal to 0, so that means you get the square root of x plus 1, square rooted, minus 2 equals 0. That look easy to solve for x? Should I do walk to solve for x? People want to see me do? Okay, cool, then I will. So whenever you see an expression where there's some complicated stuff involving an x on one side, but there's only one x, there's an algorithm you can follow. Just think about undoing everything you see on the side that has the x's, but undo it in the opposite order that you do it. So here I see x, then I add 1, then I take the square root, then I subtract 2. Last thing I do is subtract 2. How do you undo subtracting 2? Add 2 to both sides. So you will get square root of x plus 1, all that's still inside the square root, equals plus 2. And now iterate. On the side with the x, I see x, and then I add 1 to it, and then I take the square root. What undoes square root? Square. So let's do that. Square both sides. X plus 1 equals 2 squared. And what's 2 squared? You good? All right, x plus 1 equals 4, so what is x? 3. Subtract 1 from both sides. Does this look like it has x-intercept at 3 right now? No, so I could just relabel that point, but I also have an erasable pen. So it looks like I want to go through 3, 0. And some of the homeworks will say, graph this and make sure you have the right intercepts. Maybe if you find that your intercepts aren't right, maybe just draw a new copy where you force them to have the right intercepts. Feel pretty good? Nice. One last move to do with the remaining 5 minutes. Let's think about what happens when you put a negative sign next to the function or next to the input. And let's go in order. If you know what the graph of f of x looks like, how do you think you should get the graph of f of negative x?
It's inverse across either. It's inverse across the x-axis. Is that correct?
I hear a call for a flip across the x-axis. Let's actually do the same thing we did at the beginning. Let's pull up at that Desmos graph and just see. So, if I want right now f of negative x, oh no, this function has too much symmetry. I'm going to change the original function, x cubed plus x plus 1. 3x squared. Okay, there, that's better. So there's the graph of some function. Now I'll stick a negative sign next to the x. How do the purple and red functions relate? What does it look like? There's some sort of reflection that sends one to the other? Reflection over the y-axis. To get the graph of f of negative x, you reflect over the y-axis. And in practice, you can now just do it. There's the graph of some function, x cubed minus x minus 1, plus 1, doesn't matter. If I want the graph of f of negative x, I need to reflect over the y-axis. So the point 0, 1, already on the y-axis, so it's going to stay put. This point is at negative 1.1-ish, comma 0. Where will that point go if I reflect over the y-axis? Positive 1.1-ish, comma 0. And then let's just copy between. This purple bit will get reflected over the y-axis and wind up down there. This bit in blue that feel pretty okay? Nice. So one last one, I got time. What if you want to multiply the whole function by negative 1? What do you think that should do to the graph? Reflect over the x-axis seems reasonable. Let's just see if it happens in practice. Negative f of x. Does that look like it has reflected over the x-axis? Yeah. And that makes a lot of sense, right? You've made all of the output values negative. Reflect over x-axis. And you can now do that. This point at 0, 1 will become 0, negative 1. Giving you something like that. Neato! These ideas seem pretty okay? Alright. We will pick up on this on Wednesday. And I'll see you then, if not during my office hours. Have a good day.